All right, so now let's go back to our share. All right, so x plus 5 equals 7 is just a simple example of an equation. So we're solving for solutions. I think I want that to be blue. So a solution is going to be a value or values depending on the complexity of the problem. You can't have more than one solution. But in our case, in this section, you're only going to have one solution. But a value or values that will make an equation true. So whenever you're looking at an equation and you want to solve for that equation, you should be asking yourself the question, when is this true? So in other words, when is x plus 5 equal to 7? And your answer is when x is equal to 2. And so that's how you should be looking to solve your equations. You want to know when is that equation true, and the value that you plug in for x, if that is your solution, will make that statement true, because 2 plus 5 is equal to 7. All right. So we'll be solving by what I call opposite operations. So opposite operations are operations that undo what the other one does. Addition and subtraction undo what the other one does. And multiplication and division will do the same thing for each other. All right. So in other words, you want to know, you want to examine what's being done to your variable, and you want to undo what's being done to your variable. So if we go back to x plus 5 equal to 7, what's being done to my variable is I'm adding 5 to it. Your goal should be to get your variable by itself. Notice right here, x is equal to 2. I have x on one side by itself. That is what enabled me to have my solution. Once I've solved for my variable is on one side by itself, then I have solved my equation. So your goal is to get your variable on one side of the equation by itself. So if I have x plus 5 equal to 7 and I want to get that plus 5 off of the x, the next move would be for me to subtract 5. I need to undo the addition of 5. I want to get x by itself. Now your equation is set up with a right and left side, and it's set up by your equal sign. So you're talking about the right side of your equal sign, left side of your equal sign. So notice we subtracted 5 on the left side of our equal sign. Positive 5 and negative 5 will cancel. But whatever you do to the left side of your equal sign, you also have to do to the right side of your equal sign in order to keep your equivalency. So if I subtract 5 on the left, I also need to subtract 5 on the right. So on the left, I have just x. And on the right, 7 minus 5 is 2, which is what we already said would be our solution. So that is the foundation of solving all of your equations. Your goal is to get your variable by itself, and then you want to do that by using opposite operations. All right, let's try a few more. Okay, so for this next one, we have y minus 10 equal to 15. So we want to undo the subtraction of 10. So we will add 10 to both sides of our equation. Remember, once again, the equal sign is what sets up, the sides of our equation. So we're talking about right and left side of our equal sign. 10 cancels on the left, leaving you with just y. 15 plus 10 is 25. And you can always check your solution to see if it's correct by taking it and plugging it back into your original equation. 25 minus 10 is 15. Next one, 5a equal to 13. 5a is multiplication. That's 5 times a. So if you have 5 times a, then what you want to do is divide by 5 in order to get that off of a. 5 divided by 5 will give you 1. And also, let me say this. 1a is the same thing as a. So you'll never see 1a, in an expression in its most simplest form. 1x is the same thing as x. 1y is the same thing as y. It's understood that if you see the variable, then you know there's a 1 in front of it. So always keep that in mind. So here, 5 over 5 is 1. But when I come down here, I wouldn't write 1a, I would just write a. And that's 13 over 5. You do not have to write the decimal or the mixed number, unless for some reason they ask, but they assume that, if you're at this point, you're experts and pros at mixed numbers and decimals. So they're not asking you for anything but the fraction in its most simplest form. So 13 over 5 is that fraction in its most simplest form. Now, if you had something like this, and this is what I mean by simplest form, if I have 4 over 6, then you can reduce that because 4 is 2 times 2, 6 is 2 times 3, 2 over 2 would cancel just like that 5 over 5, and that leaves you with 2 over 3. So they are expecting you to do that, but you don't have to change that 2 over 3 to 0.6 repeated. So in other words, you don't have to turn to a decimal. So just throwing it out there as to the type of answers that they are looking for. You want your answer in the most simplest form. That does not mean you have to convert it to a decimal or a mixed number. Now, if you do that, that doesn't mean they're going to mark it wrong. It just means that you are giving, don't forget, you are human, and you give yourself a chance for other chances for error. So just be careful with that. If all they're asking for is 13 over 5, safest thing to do is leave it as 13 over 5. But I do get it. Some people just have to convert it to a mixed number. If you want to, that's fine, but they're not asking you to do that. All right, so last one of this type, we have x over 9 equal to 11. So x divided by 9, you're going to multiply both sides by 9. 9's cancel. Final answer is x is equal to 99. Any questions on any of those before we go any further? See if I can find some examples. Oh, I know one thing I can do is this. Every day is an opportunity for questions. So if you have them, make sure you bring them to class so we can talk about them. Make sure you're good. Let's see, let's go one. Here we have x plus 1/3 equal to 3/4. Just because we have fractions doesn't mean that we change what we would do. So we want to undo what's being done to our variable. So we need to subtract 1/3 from both sides of the equation. 1/3 cancels. Leaves me with x on the left. But on the right, we need to find our lowest common denominator. Don't forget, whenever you're adding or subtracting fractions, you need your common denominator. And in this case, it's going to be 12. That's 3 times 4. Two denominators, 3 and 4. So, like I said, just remind me of the adding and subtracting process when it comes to fractions. I need, if I'm saying my LCD is 12, then I need to turn both denominators into 12. So you ask yourself, what times 4 will give me that 12? And it's 3. But whatever you do to the bottom, you have to do to the top as well. So it's going to be 9 over 12. Down bottom, what would you multiply to 3 in order to get 12? That'll be 4. So that'll be a minus 4 over 12. You cannot add or subtract fractions without having a common denominator. So once you have your common denominator, you have on top 9 minus 4, which is 5, as your final answer. Keep that same denominator. Your answer is 5 over 12. Okay, that's a good one. This, Okay. All right, so I was just pulling some problems from the homework. Just to give us a few more examples before we let out. Let's see if we do this first. So let's say we have something like this, 2x plus 1 equal to 5. Each one that I've done up to this point were just one-step problems. Here we have multiple things being done to your variable. Remember, your variable's right here. We have 2x plus 1 equal to 5. So we are adding 1 and multiplying 2 to the variable. So once again, your goal is to get x by itself. The most efficient move to make here is to move the 1 first. You could divide by 2, but if you were to do so, then you have to divide everything by 2, which gives us fractions, and we don't want to do that if we don't have to. So the first thing we'll do, like I said, is to get rid of the 1, and that means we will subtract 1 from both sides of our equation. One's canceled on the left, leave me with 2x, and then 4 on the right. From there, divide by 2. Bless you. I saw you.
Thank you.
No problem. And then divide by 2 on both sides. Well, it cancels out on the left side, excuse me. Then on the right side, 4 divided by 2 is 2. All right, let's do another one similar to that. 6p minus 1 equal to 17. First thing we'll do is add 1 to both sides. Six p equal to 18. Again, I didn't have to write that over. Next, divide by 6. B is equal to 3. All right, questions? Any questions? All right, next one, 6x minus 5x plus 4 equal to 19 minus 9. So notice what we have here is that we have multiple terms on each side of our equation that can actually be combined. So before we look to move anything across our equal sign, we can do 6x minus 5x on the left side of our equation, which will actually be 1x. And then on the right side, 19 minus 9, which would be 10. All right, so from here, we will go ahead and finish this off by subtracting 4. X is equal to 6. All right, questions before we look at the next one? All right, so make sure we take note of the difference between this one and the last one. Notice the last one we had both of our x terms on the same side of our equation. This time our x terms on different sides of the equation. So we can't just add them together. In order for them to get access to each other, we have to take them across the equal sign. And remember, whenever we took a term across the equal sign, we had to do the opposite, use the opposite sign or the opposite operation. So remember, your goal is always to get x by itself. And once again, we have these two terms that have x involved. So it's up to you which way you want to go. It doesn't matter. You have 4 different terms to work with: 5x, 33, 4x, negative 16. You should be trying to get all of your terms with x to one side, all of your terms without x to the other side. It doesn't matter which order you go. As long as you do it correctly mathematically, you will still get the same answer. So I'm going to go ahead and subtract 4x on both sides. 4x cancels. Once again, if I decided to take the 5x to the right side, I will still get the same answer eventually. My signs will just be different as I go throughout my calculation. 5x minus 4x is 1x plus 33 equal to negative 16. Make sure you don't lose that negative 16. That's a minus 16. That means it has to stay negative throughout your process. Then from there, we will subtract 33. 33 cancel on your left. Then on the right, that'll be a negative 49. Questions? Any questions? You got one more type of problem, and I'll let you guys go for today. All right, so we have 4/5 equal to 1/5 plus 3/4 x. So, is that anything I need to see? Okay. All right. So, first thing we want to do here, well, let me say this. You can handle this type of problem one of two ways. You can deal with the fractions the way you see them, just like we did before. We had a problem that we just solved it with the fractions. Or you can do what we call clearing out your fractions. If you're going to clear out your fractions, first step is to find the LCD. LCD is least common denominator. So we have a 5 and a 4 in our denominator. So the LCD will be 20. The LCD is the smallest So your LCD is your smallest number that each denominator can divide into evenly. So 4 and 5 can divide into 20 evenly. Now, if you don't get the LCD, let's say if you got something larger, let's say if you did 40, it wouldn't be the worst thing in the world. As long as your denominators can divide into it evenly, you'll still be okay. It's just that you will have to reduce your answer at the end. It ensures that you have to reduce the answer at the end. Sometimes you will, even with the LCD, but if you use something larger, you most definitely will have to use reduce at the end. But as long as your denominators can divide into the number that you're calling your LCD evenly, you will still be okay. Next step, we're going to multiply each numerator by the LCD. And notice I said each numerator, we're not multiplying top and bottom, we're multiplying across the equation. So we're just going to multiply each numerator by the LCD. So we're multiplying each numerator by the LCD. That was a plus, right? I don't know why they look funny. So we're going to reduce or simplify. We notice 5 can go into the 20, leaves you with 4. 5 goes into 20, leaves you with 4. And then 4 divides into 20, leaves you with 5. So what you're left with is 4 times 4. No. 4 times 1. Questions before we go to the next step? All right. So now we can go ahead and solve. That will be a final step. Go ahead and solve. Because now we have a regular equation. And we would take on same thought process that we had up to this point. Subtract 4 from both sides. $12 equal to 15x. Then divide by 15, whatever's sitting in front of x. We want to get it off of x. We divide both sides by that number, which is 15. So that'll leave us with x equal to 12 over 15. Don't forget to examine your answer. Make sure it is the most simplified answer possible, and this can be reduced further. Got 3 times 4 is 12. 3 times 5 is 15. 3's cancel. And that's 4/5. Questions, concerns, comments, anything, anybody?
Can you scroll back up?
Let me know when to stop.
Stop right there. Thank you.
Not a problem, not a problem. All right. So, as you guys are finishing up writing, make sure you get into Connect Math, try it out, see if you're getting stuck with anything. Make sure you can, get into your assignments and all the good stuff like that. Once again, I haven't put a due date out there for any of your assignments, so nothing is due by next class. But you do want to get started. You don't want to be behind. You want to progressively do this stuff as we go throughout the course. So, you don't want, us to be in 4 or 5 and you still haven't started 4-1 yet or something like that. So you just don't want to get too far behind. Try the stuff out. We'll do another one or two like this to reinforce this process most definitely, and do some more on next class. But I won't throw one in there right now and try to rush anything. So if you have anything else, I'm here listening. If not, I will see you guys on Thursday. All right.
I got one
Have-
quick question.
Yes, sir.
I'll be honest with you.
Mm-hmm.
I got that problem wrong. And
Hold on. So you went in and out. You said you got I got it wrong. You got it
I got
wrong.
it wrong. I got it
Okay.
wrong. And what I did was I took the, let me go back.
Mm-hmm.
I took the 1/5 that was positive and slid it over and made it negative. Then I subtract them.
That's fine.
Okay.
That's fine. So now, if you want to go that route, only reason I went this route is because this is a process that we're going to need moving forward. Let's say if you didn't use clearing out of fractions.
Then I got 3/5.
Mm-hmm.
So it's 3/5 on this side equals 3/4 of x.
Yep. So you saying you subtracted 1/5 from both sides. That cancels, leave you with 3/5. Because remember I said that there are two ways of doing it. You can do it with the fractions or clear them out. So I was just going over the clearing out process, but this is where you are right here, correct?
Yes.
What was your next move?
Next move would be to move 3/4 over to the other side, make it positive, make it negative.
Got to be careful. Don't
Okay.
forget, this is
Division.
multiplication.
So you have to
Yep.
multiply the opposite.
So you're going, so you're like you say, you're gonna have to divide in order to cancel out the multiplication. So now, whenever you're dividing by a fraction, that means you're actually going to multiply by the reciprocal.
You're right. Flip it.
Yep. So that means you're actually multiplying both sides by 4/3.
Thank you. I'm a little rusty.
No, you're fine. You're fine. Yep. So you're multiplying both sides by 4/3. So 4/3 over 4/3, just in case anybody needs to see the math on it. Let me do it like this. That's 12 over 12, which is 1. So that's why that cancels out. Or you can just look at it as 4 cancels, 3's cancel. Either way, you're left with just x on the right. And then on the left, the 3 over 3 will cancel, leaving us with 4/5. And that should have been our answer, if I'm not mistaken. Yep, 4/5.
Thank you.
Not a problem, not a problem. All right, anything else, anybody else before we close out?
I forgot to do the reciprocal.
Yeah, it'll get you. It'll get you, man. So it's all good, though.
So I have to
I'm glad.
flip it when I cross the equal sign.
Say that one more time.
Flip it when I cross the equal sign.
Yep. But I'm glad you asked. Glad you asked. Make sure we get that cleared up. So,
Thank you.
not a problem. Not a problem. So it's 10:45. So I'll let you guys go. See you again on Thursday, and we'll cover some more stuff.
Thank
All right. Not a problem. You have a good one. Everybody have a good one.
Thank you and have a good day.
Do the same.
Thank you.
No problem. You have a good one.
Now I got to figure out how to log out.
Well, when I press end, that'll take care of that.
Okay.
Yeah, so
I'm not used to this stuff.
once you go over and look on the bottom where it says mute and video chat, go all the way to the right, and once you see a little box that says leave, once you click that